is what we had yesterday. We were talking about high tide and low tide, you know, and all that. And I wasn't sure if it would be helpful, but I instead of using, since I'm looking at a whole day, I'm using like military time instead of like 9 o'clock. You know what I mean? I don't know if that'll help or not. I don't know. Doesn't matter. Doesn't matter. I just did that to see if that might help us. Okay, so where were we? I think we'd answered A. At what time on the 4th of July did the first low tide occur? Because they told us we had a low tide at 3:48, and they told us we had a high tide at 9:36. Right, they told us those two things. Okay, and we need to back up and find another low tide. Would it make sense to you that the distance from here to here is going to be the same as the distance from here to here? So if this looks like it's 6 hours and 12 minutes. So if I back up 6 hours and 12 minutes, what's that going to put me at? 3:24 a.m. Is that what we got yesterday when we did it? Good. Okay. So that was the first. Okay, now here's what I'd like you to think about for a second. In this sine or cosine, whichever way you're looking at it, clearly has a vertical shift, right? Because the curve is not oscillating across the axis. Remember, normally they're going to be oscillating across the x-axis. This one isn't. It's been lifted up. So can you figure out what its axis is? What is its axis, would you think? It's not hard. It's halfway between the high point and the low point. So what's halfway between 2.1 and 2.7? 2.4. So the question says, what is the approximate depth of the water at 6 a.m. and 3 p.m.? Now, at 6 a.m., wouldn't 6 a.m. be about halfway between these two right here? Now it says approximate depth of the water. What do you think the approximate depth of the water is at about 6 o'clock in the morning? Or at 6 o'clock in the morning. It's about 2.4, is it feet? Meters. So 2.4 meters. Does that make sense to you? Now where is 3 o'clock p.m.? Isn't 3 o'clock about in the middle of here? So the answer to that would be also about 2.4 meters. Easy. What was the first time on July 4th when the water was 2.4 meters deep? So we know it was 2.4 meters here. I just rough sketched this in, so I don't know. Is there a time over here when it was about 2.4 meters deep? Well, if there is, okay, do you have any idea how we might figure that out? Remember, this is like 3 o'clock, and this is like 6 o'clock. So doesn't it make sense that this would be like 3 hours before 3 o'clock? So what would you say? What was the first time? Around midnight? Around midnight. It was about 2.4. And you're approximating. You're approximating. All right, so that takes care of that. That wasn't so bad. Did we do all the parts then? Yeah. Okay, so now, big day. Now we're going to graph the other functions. We had kind of a head start with, did I turn this on right? Yeah. Okay. We had a head start with the sine and cosine because they were our BFFs. But you might have never seen the other four. So luckily, they're right there. A, B, C, and D are just the basic functions. So we're going to start with those. Okay? So we'll start with the basic functions. We're going to sketch a tangent. If I had more time, I'd go through this and show you why it is the way it is, but we don't really have time, so we're just going to sketch a tangent. Tangents, you remember, are undefined sometimes. They have asymptotes. In fact, all four of the ones we're going to talk about today have asymptotes. They're all undefined at different places. So with the tangent, drop in an asymptote here and an asymptote here. Put a 0 right there on the origin, a dot, x-intercept, and then sketch a little curve that looks like your cubing function. Now, it's not a cubing function because it has asymptotes. The cubing function just keeps on going forever, but this one is confined between these two asymptotes, and that's one period of the tangent. You could draw another one here and another one here, but we only need to draw one. And the asymptotes are at negative pi over 2 and positive pi over 2. And that is your tangent. Its period is simply asymptote to asymptote, right? That's a period. And that distance is pi. Would you agree with that? Its amplitude is non-existent because amplitude involves height, and this curve has no height. So there's no amplitude. Now, we can still put numbers in front of the equation for sure, and that will change the curvature. So instead of being this shape, it might be, fatter, more like that, if we had a certain number out here in front. But in terms of amplitude, there isn't amplitude. Please don't say 0. Either write the word none or put an empty set. You simply can't discuss amplitude with a tangent. Now, the cotangent has very similar features. Here's a huge difference though. The cotangent has an asymptote on the origin and another asymptote over here. And since it's the reciprocal of the tangent, it's decreasing. It's upside down of the tangent. You turn it over, so it's upside down. This is called an increasing function, obviously, and this is decreasing. The period is the same, so this is at pi, and this is at pi over 2. The x-intercept, or the 0, is right smack dab in the middle of the period. So your period is pi, and your amplitude is again non-existent. Big, huge thing to remember. What is the standard period of sine and cosine? 2 pi. Standard period of tangent is pi. Okay, it's different. It's different. Okay, so that takes care of tan and cotan. They're very different shapes, for sure. Now, what about the cosecant and the secant? Well, who remembers what the cosecant is the reciprocal of? Sine. So, as long as I've done this, I still always sketch a sine first. So I'm going to go ahead and just sketch my standard sine. And this is something you should know how to do. I'm going to do it with a dashed line. There's my sine curve. And I'm sketching a sine because I'm doing a cosecant and it's the reciprocal of the sine. Now, once you get it drawn, your sine curve, remember the cosecant is the reciprocal. So at these 3 points right here, the value of the sine is 0, right? These are zeros. Well, if you take the reciprocal of 0, what happens? What's the reciprocal of 0? Undefined, right? 1 over 0, undefined. So if you're undefined, you have an asymptote. So every time I cross the axis, I'm going to have an asymptote. So it helps to have my sine curve drawn, because wherever it crosses the axis, that's where my asymptotes are going to be. And then, see this hill right here? You're going to take the reciprocal of it, so you're simply going to flip it up. So the top of the hill, they touch right there, and then it flips up. And then guess what? Guess what this one does? Same thing, only it flips down. And that is your cosecant. So what is your period? 2 pi, just like the sine, 2 pi. It comes from the sine, so it's 2 pi. And what's your amplitude?
1.
Ah, be careful. There is no amplitude. Now, is the 1 an important number? Absolutely, right? It gives me a minimum and a maximum for those 2 little pieces of the graph. But amplitude, remember, deals with height. Does this curve have height? No, it goes on forever and ever. So, no amplitude. The only functions that have amplitude are sine and cosine. Nothing else has amplitude. Okay, all right. Now, I bet you could do a secant without my help. What are you thinking to do a secant? Maybe start with a cosine. Just dash it in. I don't care if you dash it in or not, it doesn't matter to me. And this one's going to look very strange, so do remember that it keeps going, right? It goes forever and ever. Now, every time it crosses the x-axis, here and here and here and here, its value is 0. When you take the reciprocal of 0, 1 over 0 is undefined. So you're going to drop in asymptotes every time it crosses. Now, in the main part of the picture, 0 to 2 pi, that would be the only 2 asymptotes. But do you understand that there's another one over here, and there's another one over here, and they're all over the place? In between these 2 asymptotes right here, these are the main asymptotes if I'm going 0 to 2 pi. In between, you see a little valley, so I don't think it's a stretch to flip it, right? Just like we did with the cosecant. Oscar, you doing okay?
Yeah.
Okay. Now, this hill is going to get flipped, but remember, this is kind of extra part. So when I flip the hill, the only part that I actually have is this part, because this part would be over here. And remember, I'm graphing 0 to 2 pi. And then likewise, this hill, that's really all I have when I flip it, because there's 2 pi and that's the end. So the red solid is a picture of the secant from 0 to 2 pi. I have no issue with you graphing more if you want to make the picture look more normal. What's the period of the secant? 2 pi. What is the amplitude of the secant? Doesn't have one, right? Okay, so that's the first 4. I guess I did a lot of order, but anyhow, that's the first 4 there, A, B, C, and D. Now the rest of this is going to be variations of these. Yes, Ms. Freeland?
So for the secant, we graphed the middle valley and then those two lines on the
Uh-huh.
axis.
If you're going 0 to 2 pi,
Okay.
which is the standard period,
Okay.
but you can always graph more. But that label is 2 pi, and that label is 0, so that's the part of the graph that we normally would graph.
Even though it's past the asymptote?
Oh yeah,
Okay.
because you gotta go all the way to 2 pi. You gotta have a hill and a valley. It's just with the cosine, the hill is split. So you got half of it over here and half of it over here. All right, so let's try 2 tan 2x. Now, just to help myself out, I'm going to go ahead and sketch my regular tangent over here. I need to remember that this is what a regular tangent does. Oh, this is fine, don't yawn. Now, we also, okay, so has there been any shifting sideways or anything in this problem? No. So there's going to be an asymptote here and an asymptote here, and the curve is going to do this. That's what tangents do. Now, if we move it, then we can't really start off that way. But we're not moving this one. We're just changing its size a little bit. Normally, what's the period normally? Normally the period's pi. Well, this period has been divided by 2. Remember, this number divides the period. All the functions. That divides the period. Now, what does that mean? That means that the distance between my asymptotes is now pi over 2. That does not mean this is pi over 2. It means the distance is pi over 2. So if that's right in the middle, then I'm going to have to go forward and backward how much to get a total distance of pi over 2? Half of pi over 2, which is pi over 4, right? Pi over 2, half of it would be pi over 4. So this is pi over 4, and this is negative pi over 4. I started at the origin and went forward half the period and backward half the period to get the whole period. Now, when I sketched it, I just randomly sketched it in. Does that 2 have an impact? Yes. It straightens out the curve. The bigger that number is, the straighter this becomes. On our sketches, we're not using graph paper or anything, so I don't want you to worry about that 2. Don't worry about it. This is fine. But I do want you to know in your head that it does make the curve straighter. Okay? So a straighter curve would look like this. See how that's straighter? And a fatter curve would look like this. And that's controlled by that number, but I don't want you to worry about it, okay? I'm not paying attention to it, but you should know it. Now, the only time you really have to pay attention to that number is if it's negative. Because what would a negative out here do? Turn it upside down, just like negatives always do. So you got to do that part. But otherwise, don't worry about this number in a tangent or a cotangent. All right, so what do we got next? Now we've got a cosecant. So let's graph our sine first. So I know the problem is negative 3 cosecant 1/2 x minus pi over 3. But I'm going to graph it as a sine first. Okay, let's start with the sine. So you know what a sine looks like. That's a sine. Unfortunately, I don't get to start at the origin on this one because of this, right? So I will start at positive pi over 3, because I'm going right. So I'm going to have my, oh wait, and there's a negative in front of it. So that means the valley comes first. Would you agree with that? And now I need to label all this stuff. So I can't begin to do that until I know what my period is. I have to know what this distance is. So I know that for a regular sine curve, the period is 2 pi. This one has been divided by a half. So the period is 4 pi. Now, that means that from here to here is 4 pi. Right? So what's that going to be? Figure out what that is. If this distance is 4 pi. (13 over 3). Very good. 13/3 pi. How did she do that? She said if somebody starts on the number line at 1/3 and takes 3 steps, where are you? Well, that's, oh wait. No, that's not right. Oh wait, I'm adding 4 steps. That's right, so it is right. I'm sorry, you don't take 3 steps, you're taking 4 steps. Our period's 4. So that's 12/3 and 1/3, so that's how she got 13/3. What's in the middle of 1 and 13? 1 plus 13 divided by 2. What's in the middle? 7. What's in the middle of 1 and 7? 4. Remember, you're just averaging. Add them and divide by 2. 7 and 13 would be 10. And they're all pi's and they're all over 3. And my amplitude is 3. So if this had been a sine curve, we would be done. Does that look good to everybody? That's a nice sine curve. But it's not. It's a cosecant. So I have to drop in some asymptotes. Where are they? Where at my x-intercepts are my zeros. So I'm going to have one right here. I'm going to have one right here. And I'm going to have the one right here. The cosecant is the one that looks normal. It's got a parabola opening down and a parabola opening up. And the red is your cosecant. Let's list our stuff for that. We already said what the period was. We said the period was 4 pi. That makes our frequency 1 over 4 pi. We talked about that yesterday. Amplitude. Now remember, you're doing a cosecant, so the amplitude is non-existent. Phase shift. We had one. What was our phase shift? Pi over 3 positive. Right. Pi over 3. And this does not have a vertical shift. If we did want to vertical shift it, we would do that at the end. We would take these parabolas and we would lift them up or down, whichever direction we're going.
And you can keep all those labels on there. Those are still accurate even though it's a cosecant.
Oh yeah, oh no, those are still accurate, yeah. So the relative minimum or relative maximum of the curve here is at 4 pi over 3. The relative minimum is at 10 pi over 3. Yeah, those labels are very important. Yeah. All right, let's try G. Now, we do not have any shift here. And that's actually good news because I can jump in immediately and say, I don't know what the labels are, but this is a cotangent. So I'm gonna have an asymptote here and an asymptote here because it hasn't shifted. And cotangents have an asymptote at the origin, unless you've moved it. Now, how far apart are these asymptotes going to be? Normally, they would be pi apart. But this time, how far apart are they going to be? 4 pi? Isn't my period going to be 4 pi? Because it's pi divided by a fourth. So I have an asymptote at 0, and I have an asymptote at 4 pi. Now I'm going to sketch in my curve. Be careful. It's a negative cotangent. So it actually is going to have the shape of a tangent. And I kind of, on my own, made it steep, not very curvy, because that's a 4. It's a big number. Straightens it out. But that's what it looks like. Now, I never want you to think that a negative cotangent is the same as a tangent, because it's not. The asymptotes are in different places. The shape is the same, but the graph isn't the same. Because remember, tangent has asymptotes on either side of the origin. So we have our cotangent asymptotes, but we have a tangent shape. Is that easy? Okay, everybody all right with that?
Yeah.
Okay, super. We're doing great. Isn't this fun? I'm waiting all day for this. We may not do all of these. Let's see. All right, y equals 1/3 secant. Okay, what's wrong with equation H? You have to take the 2 out. So I'm going to keep the 2. I mean, there's nothing wrong with the 2. It just has to come out of the parentheses. And what's that going to make this? No, it wouldn't be over 2. It'd be over 8. Remember, okay, so think about why it's not over 2. If you put it over 2, what happens when you multiply these together? You get plain pi, right? And that isn't what you wanted. Remember, factoring is division. Factoring is division. So when you factor out a 2, you're dividing by 2 or multiplying by 1/2. Ellie?
So why did we not factor out the 1/4 in the last one?
Because there's no phase shift. If you have 1/4 x in parentheses and you have 1/4 x like this, aren't they exactly the same? The issue here is that phase shift. It wouldn't make any difference. You could do that if you wanted, but it's not necessary. It doesn't change anything because it's still just a coefficient on x. Read.
How does it become 4 pi?
If you take 2 over 1
No, I'm
times,
talking about the last one. For the 2.
when you divide by a 4, that's the same as multiplying by 4 over 1, right? Jesus?
Can you do nothing with like the negative part at the front or?
The negative turned it upside down. So a cotangent doesn't look like this. A cotangent looks like this. So the negative turned it upside down, and it made it straighter. But I told you not to worry about the straightening out part, but it turns it upside down. That was important. There is no amplitude. So if you were telling me, if you were listing, period and amplitude, you would say none. Now this 1/3 is going to be important to the picture because when I sketch it, first of all, I got to shift, so I'm going to be starting over here at negative pi over 8. It is a secant, which means I'll start with a cosine. So I'm just gonna, here's my starting point, I'm just gonna sketch in here's my cosine. I know eventually I'm gonna put in asymptotes and all that stuff, but first let's get our labels under control. What's the period of a normal cosine? 2 pi. This one has been divided by 2, so my period is just going to be pi. Now, this time I'm starting at -1/8, and I'm taking 1 step, pi, 1 pi. So if I start at -1/8 and take 1 step on the number line, where am I going to be? I'm not sure how else to explain this. Here's the number line, right? Here's -1/8. You need to travel 1 unit. So if you travel 1 unit from -1/8, where are you going to end up? 7/8. 7/8. Take -1/8 and add your period. -1/8 plus 1 is 7/8. What's in the middle of -1 and 7? 3/8, because -1 and 7 is 6, divided by 2 is 3. What's in the middle of -1 and 3? -1 plus 3 is 2, divided by 2 is 1. 3 plus 7 is 10, divided by 2 is 5. So there are my labels. If you want something that's in the middle of something, you add them together and divide by 2, and that's how you find the middle. So that's a beautiful little cosine. Now I'm going to drop in my asymptotes, and I drop them where it crosses the axis. Right? Now, this part's not broken. I have the whole valley, so I'll flip that over. Now remember, this keeps going, so you can see a parabola here, but technically you're only drawing the first part of it. And similarly over here, you're only drawing this part of it. The whole thing is there, so if you want to draw the whole thing, you certainly can. Our period was pi. What was our amplitude? 9. Phase shift was -pi/8, or left pi/8. And our frequency was 1/pi, the reciprocal of the period. Okay, I guess we better do I because it's got a vertical shift in it. And then we'll go ahead and do J because it's a tangent with a shift. And then that's enough of this, I think. So let's go ahead and do the next problem because there's a vertical shift. How do I know there's a vertical shift in the next problem? Because the number on the end, right. So that tells me I've got a vertical thing happening. So here I go. Whoops. It's another secant. So y equals 2 secant. This 1/2 is already factored out, so I don't need to worry about it. So everything's ready to graph. Here we go. I'm going to start with my cosine. So there's my nice little cosine setup. I'm going to start at pi/6. cosine's gonna look like this. That's what a cosine looks like. What's my period? Oh, I'm not doing anything with this till the end. Okay, so just pretend that's not there for a minute. What's my period? What'd you say? Well, the normal period's 2 pi, but what's happened to this one? Whoa, guys, divided by a half. Dividing by a half is the same as multiplying by 2. So the period is 4 pi. So that means I have to find this label. I'm going to take 1/6 and add 4. What does that give me if I take 1/6 and add 4?
25/6.
Thank you. 25 pi over 6. 1/6 and 24/6, getting a common denominator. What's in the middle of 1 and 25? 13, good. And what's in the middle of 1 and 13? 7. And in the middle of 13 and 25? 19? Don't you get 38 there? Okay. All right, that's my cosine, right? Now, I'm going to go ahead and do my flipping here. Oh, this should be a 2, not a 1/2. Kind of what I was thinking. I think I looked at that number right. My amplitude's 2, right? So let me fix that. Okay, that looks better. I can't believe no one caught that.
Not bad.
So the amplitude's 2, well, the cosine is 2. All right, so now I'm going to drop in my asymptotes. I'll drop one here. I'll drop one here. I'm going to flip my curve. And there is my secant. Now look at that carefully. Do you agree that's my secant? Now the problem says take your secant and add 1 to it. So I'm going to take the red curve and move it up 1. So asymptotes aren't changing. They're staying exactly the same, right? But everything's coming up 1. So the blue is the answer to the question. So there's nothing different about a vertical shift. You do it at the very end. You go ahead and graph it as though it weren't there, and then up, down, whichever direction it's going. So the blue is the final answer. When you're doing these, if you have colored pencils or something, it's helpful. Or erase as you go, I guess you could erase some of that. Is that okay? All right, let's do one more. Let's do one more.
Wait, do you have to fill out like the frequency and everything?
Yeah, but we kind of already talked about it. The period's 4 pi, so the frequency's 1/4 pi. There is no amplitude because remember, this is a secant, so there's no amplitude. The phase shift was pi/6, and the vertical shift was 1. So that little chart is just a way for me to get additional points. All right, here we go. One more. We're going to do this tangent because it has a shift, and I don't think we've done a tangent with a shift yet. So let's do it. Uh-oh, we got a problem with a 1/2 again. Would you agree? So let's see if we can pull that out. Anybody wanna take a stab at what goes in there?
Pi over 3.
Pi over 3! Whoever said that, you are my hero. Absolutely. And before anybody says, why? Look, if you multiply it back, don't you get pi over 6? That's what you gotta do. So whatever you write here has to give you pi over 6. So if you were thinking something else, you were not doing it right. Factoring is division. Dividing by a half is multiplying by 2. Very good. Okay, that just made my whole day. All right. Now, I'm going to graph a tangent. And normally, in a tangent curve, at the origin, which is the beginning of all things, at the origin, there's a dot. That dot has been moved. That dot is now going to be at pi over 3. So there is a dot at pi over 3. When you phase shift tans and cotans, you phase shift the origin. Okay, so wherever the origin, whatever was going on at the origin in the original picture, that's what gets moved. So the dot gets moved. Now, I know it's a tangent, so there's an asymptote over here and an asymptote over here. It's a positive tangent, so I know it looks like that. Right? The only thing I gotta figure out is, where are the asymptotes? Okay? So, what is the period of a normal tangent? Pi. But this one has been divided by a half. So this period is 2 pi. That means between my hands is 2 pi. That dot is right in the middle of that. So to find these asymptotes, I'm going to do what? Add pi and subtract pi. Won't that give me 2 pi? So I'm going to add and subtract half the period. So if I add a pi to this, that gives me 4 pi over 3. I'm adding 3/3. And then if I subtract, I get negative 2 pi over 3. 1 minus 1/3 minus 3/3. Done. That's it. So the period is 2 pi, the frequency is 1 over 2 pi, there is no amplitude, the phase shift is pi over 3, and there is no vertical shift. All right, got it? Okay, well that's enough graphing, so we won't do the last one, although you're certainly invited to do it on your own if you want a little bit more practice. Now we're going to solve some calculator problems and some no calculator problems. We're going to do some equations. Okay? Here we go. We're solving between 0 and 2 pi, which means we're going to answer in radians. And we are solving the equation secant equals 2. All right. Any idea how we are going to figure out what angle has a secant of 2 without our calculator? What might we do first? Exactly. I mean, when in doubt, draw a picture. Draw a picture. So I am going to make a triangle. Now, I have at my disposal 4 possible triangles. Now, they all 4 aren't going to work. They might in some problems, but not in this one. Because this is a positive number. Secant is associated with cosine. Cosine is associated with x, and it's positive. So do you understand that this picture and this picture won't work this time? Because over here, x is negative, but secant's cosine, and cosine's x variable, right? So I gotta be positive x. Now, the secant is 2/1. These two triangles are the same. The secant is 2/1, which would make this √3, which would make this 60 if I were in degrees. How many radians is that? 60 is 1/3 of 180, pi/3. So that angle is pi/3, and so is this one. The two triangles are always exactly the same. So my answers from 0 to 2 pi, that's once around, my answers are that angle, which is pi/3, and then this angle, which would be what? What would be the measure of that blue angle? What? Well, in degrees, it would be 300. Absolutely. What is it in radians? You're right, 300. What would it be in radians? Go ahead and change it. If you can't, I mean, if you can do it in your head, great. If you can't.
How did you get pi/3?
Did you get 60? Okay. 60 is 1/3 of 180. And if that, I mean, if you, your alternative is to set up your proportion and figure it out that way. But these angles are just fractional pieces of 180, so they're easy to do without doing that. Guys, all the way around is 2 pi, right? So what if I just took 2 pi minus 1/3? Wouldn't that work? 2 whole pi's minus 1/3? 5 pi/3 is the other answer. Yep. However you arrived at it, it doesn't matter. If you started with 300 and did your proportion, that's fine. But remember, a revolution is 2 pi, so you can subtract. All right, do I have time to do one more? Yes, I do. Don't do that. Yes, I have time to do another one. So cotangent is negative √3. All right? So cotangent is negative √3. Now again, you have the same 4 triangles as options, but you got to figure out where it would be appropriate because the cotangent has to be negative. Now, sine is y, cosine is x, but tangent and cotangent are a combination of both. So if that's going to be negative, then doesn't one of them have to be negative and one of them have to be positive?
Yeah.
So where does that happen? Second quadrant is one option. Where's the other place?
2 and 4.
2 and 4. Yep. Quadrant 1 or quadrant 2 or quadrant 4. So you only have to do one triangle. You don't need to do them both. So negative √3/1. Now remember, this is cotangent. So cotangent is adjacent over opposite. How big is this angle right here in degrees or radians? I don't care what is that. That's a 30. So that's pi/6. So in radians, because I was directed to answer in radians, my reference angle is pi/6 or 30. 30 is not an answer, no, because you have to be in quadrant 2 and you have to be in quadrant 4. So we need to know the measure of the blue angle and the measure of the red angle. So what do you think? You can give it to me in degrees or radians. We're gonna have to change it to radians, but if you got it in degrees, we'll take that.
5 pi over 3 again?
5 pi over 3?
Oh, no.
This would actually be 5 pi over 6. Because this is pi, and it's a sixth before that, so that would be 5/6. And then this one would be 2 pi, except for 1/6. That is the whole revolution, except for 1/6. So that would be 12/6 minus 1/6. So that's 11 pi over 6. Now, if that is more than you can handle, then you need to recognize these are 30s. So the blue angle would be 150, which is 180 minus 30. And the red angle would be 330, which is 360 minus 30. And then change those into radians. So pi over 180 equals something over 150, and then do the same thing with 330, and you will get your radian measures. But when the directions look like that, that means you're answering in radians. Okay? Good stuff. All right. Looks like next time, which I don't know when that is for you, Tuesday? Maybe? Oh, it's not till Wednesday. Whenever I see you again, we will finish this section, so that homework will be 2 days after that. So I'll figure out what that is. Your 4-4 homework is due Monday. If you get it done tomorrow, we want to turn it in, that's great. Otherwise, you'll have to email it to me on Monday, okay?